everyone. We're back with lesson 16 of Unit 6. So again, we're still talking about features of trig graphs. The only thing we're adding today, you might notice the only thing we really haven't talked about is what this b value here represents. And it turns out the b value helps us determine the period of the graph. The period, remember, is how often the wave cycle repeats itself. So we've talked about how, for example, the cosine graph starts at 1, goes down to -1, and then back up to 1. And then the sine graph starts at 0, goes up to 1, down to -1, and then back up to 0. All right. So how often that repeats itself is known as the period. So this is what we use that b value for. The b value helps us determine the period. All right, and then we could also find it from the graph. Okay, so find 2 consecutive max points or 2 consecutive min points and subtract the 2 x values. So what we're going to do today is we're going to take all of this stuff, midline, amplitude, horizontal shift, and period, and we're going to apply it, just like we did earlier, to a concept of a windmill, or actually, in this case, we're going to apply it to a Ferris wheel, but we can use the same kind of concept with Ferris wheels that we do with windmills. So with that in mind, let's go ahead and take a look at the examples for today's lesson. Okay, so the world's tallest Ferris wheel is in Las Vegas. The height h in feet of one of the passenger seats on the Ferris wheel can be modeled by the function, and there's our function right here, where time t is measured in minutes. Now, what I want to do before we answer the question is just to show you that we can actually take the function and we could rewrite it. So 2 pi t over 30. And I could write that plus 275 at the end here to make it look a little bit more familiar to what we've seen in the past. Okay, so number 1, what is the diameter of the Ferris wheel? Explain how you know. So if we go back to our lesson notes, okay, we know that the length of the windmill blade, or the radius, in this case we're looking at the radius of the Ferris wheel, is going to be represented by the amplitude. How do we find the amplitude? We look at the a value, the absolute value of that a value, the number that's being multiplied by sine. So in this case, the number that's being multiplied by sine is the 260. So that tells me that the radius of the Ferris wheel is 260 feet. The radius is 260 feet, okay? Now, that is not the diameter, okay? The diameter, remember, is the length all the way across the circle through the center. So the diameter, remember, is equal to twice the radius, okay? 2 radii make a diameter. So to figure out the diameter, I have to take the 260, which was the radius, and multiply it by 2. So 2 times 260 is going to be 520. So to answer number 1, what is the diameter of the Ferris wheel? Okay, the diameter of the Ferris wheel is going to be 520 feet. So 520 feet. Okay. How long does it take the Ferris wheel to make a complete revolution? Explain how you know. So think about what that means. They're asking, how long does it take for the Ferris wheel to make one full, complete rotation? In other words, that's asking for the period. Okay, so to find the period, let's go back to our lesson notes. Okay, the period, we're going to use that b value that's being multiplied by x, or in this case t, inside the parentheses. So it's the number that's attached to x or t or theta inside the parentheses. So the formula is 2 pi divided by b. Okay. In this case, if I use a different color, the number that's being multiplied by x, or in this case t, is the number that's being multiplied by x, or in this case t, is this part right here, 2 pi over 30. Okay, so that means in order to figure out the period, I need to do 2 pi divided by 2 pi over 30. So I need to calculate that. 2 pi divided by 2 pi divided by 30. So if you can't do that, if the fractions kind of mess you up, you can do it in Desmos. So that's what we're going to do. So if we clear out Desmos here, again, we're doing 2 pi divided by, and then I'll put this in parentheses, 2 pi divided by 30. And if I do that, notice I get an answer of 30. So the period in this case is 30. Okay. The period in this case is 30. So how long does it take the Ferris wheel to make one complete revolution? It takes 30 minutes to make one complete revolution. Okay. Number 3, give at least 3 times when the passenger seat modeled by F is at its lowest point. Okay. Give at least 3 different times in which the passenger seat modeled by F is at its lowest point. Okay. So we know that the amplitude is 260. Okay. We know that in this case, the midline is going to be 275. So if we go back to our lesson notes here, okay, the midline of the sine graph represents the height of the center of the windmill blade. The angle position where the windmill starts represents the C value. So we're going to assume that we're going to start directly right of center. So if we start in the 0 degree position here, or the 0 radian position, okay, what we need to do is we need to figure out how long does it take to get down to the lower position here. Okay. We know that it starts here because there's no C value. We know that this is 275 feet up in the air. Okay. So to figure out how long, we know it takes 30 minutes to go around the whole thing. We're going to assume that the Ferris wheel stays at the same speed throughout the whole time. So assuming the Ferris wheel moves at a constant speed, if it takes 30 minutes to move around the entire circle, well, then how long is it going to take to move around? In this case, it'll be 3/4 of the circle. So to do that, I need to take 3/4 or 0.75 and multiply that by 30. So what is 3/4 of 30? Let's go to the calculator. So 3/4 of 30 is 22.5 minutes. Okay. So that means it takes 22.5 minutes to go around 3/4 of the circle. So that's one of the times in which it is at its lowest point. Okay. So what they want to know is, let's say I go around the Ferris wheel multiple times. So how long would it take me to get back to the slowest point? Well, I know a whole cycle takes 30 minutes. So the next time I'm going to be at the low point is going to be at 22.5 plus 30 minutes later. So that's going to be 52.5 minutes. So that's the second time I'm going to be at the low point. And then the third time is going to be at 52.5 plus 30. So that's 82.5 minutes later. Okay, so those are 3 times in which I'm at the lowest point. Okay, so I figured out the first one by taking 3/4 of 30. And then I know that 30 minutes later, I'm going to be back there because the whole cycle takes 30 minutes. Okay. Sketch a graph of the height of the seat on the Ferris wheel for at least 2 revolutions. So what I'm going to do is I'm actually just going to graph this on Desmos. Okay. So I'm going to graph this. So 260 sine. So 260 times sine of 2 pi over 30 times t, but in this case I have to use x. So 2 pi over 30x plus 275. So obviously I'm going to need to do some zooming out here. Okay. So I'm going to mess around with the window here. Obviously I don't need to worry about negatives since we're talking about a Ferris wheel here. So let's go 0 to 90. And I know that the center is 275 feet off the ground. Okay. So let's go to 450 feet. All right, and here we go. Okay. So notice at 0, I'm starting at 275 feet in the air, and it takes me 30 minutes to get back to that point. Okay. And then the second revolution would be here to here that it takes to get back to that starting point. And we could also see our answers from before. We can see at 22.5 minutes, at 52.5 minutes, and 82.5 minutes, it's at its low points. Okay. So again, the purpose of this activity is to take this concept of a Ferris wheel and apply it to everything we know about the feature of trig graphs. Okay, again, we have the midline, the amplitude. Okay, we talked about horizontal shifts. This particular one didn't have a horizontal shift. But the only thing we added was the concept of a period, how long the cycle takes, how often it repeats itself. All right. So that is it for this lesson.